All right, algebra nerds. So we're about to transition into assignment number 16, which is over inequalities. And I just want to share with you that over time, I've come to believe that the methodology I'm about to share with you is the best way to do it. I did not invent it, but I will tell you that this can be taught in a variety of ways. And in my opinion, it makes sense to show you one way that will do every kind of inequality that I will ever ask you to do. I used to teach it in a way where there were 4 different ways to do it, and you had to identify which way was appropriate for the question. I've come to believe very strongly that this one method, this one thought process will work very well. And look, Mr. Sonogram is going to get to live his dream of being a game show host as well. So you'll see that moving forward. Let's look at this. We have 4 inequality relationships, and from left to right, you would see this in your notes, but you realize hopefully that these symbols would be less than, greater than, less than or equal to, and greater than or equal to. Those are relationships. I'm going to use the analogy of dating, because dating is all about relationships, to hopefully understand this. So on example number 1 here, you will note that we have a fraction over here, and basically to me, it's as if that fraction right there put out a personal ad that said, I'm looking for all the values of x, all the numbers that will make that fraction either greater than or equal to 2. So this is the personal ad seeking either a greater than or an equal to relationship. In my opinion, it makes sense to start with the relationship that we're familiar with. Let's focus on the equal to relationship that is built into that statement. So again, if you go to the notes that were uploaded, I'm beginning to discuss what we call in math critical values. They're very important. And the first type of critical value would be to change or focus on the equal to part of that. That's 2 relationships. What numbers make that fraction either greater than or equal to 2? Let's start out with the equal, because that is something that we've covered before. So I pull this off to the side. By the way, I would suggest you leave this open underneath here. And let's figure out what numbers, what values of x will make this equal the number 2. All right? And that ought to be a flashback, shouldn't it? And that would take us back to the fact that that's a linear equation, because those x's are both to the first power. So once again, when we do the equations, this should be flashback. Right? That's flashback. And so we'll go back and solve that equation. And I would point out to you that this particular equation would be linear, because the x is to the first power. So we'll clear fractions first. Clear fractions? This is all stuff that was covered in the past. This is assignment 8 over 1. So when we apply this to the fraction, don't those cancel and leave just x minus 15. And then on this side, we would distribute the 2 into the parentheses. My hope again would be that everybody is looking at this saying, oh, this is so assignment 8. That was February. Let's see, and then you separate the variables from the constants. So in this case, we will start moving things from one side to the other. This is all very old stuff that we've done many times. I hope it still is in your brains. And then how about we bring over the 2x? Now let's see, that would be a 1x minus 2x, which is negative 1x. And then we'll divide out the negative 1. So the equation part is old stuff. And so I will warn you that as we continue through these examples, Mr. Sauerkraut's going to go through them pretty quickly, because the equation part is old stuff. All right? Flashback. So it appears to me that x would equal 5 over here on this side of things. So there you go, 5. 5 is what we would call a critical number here. Negative 10 divided by negative 5. Yeah, okay. Sorry, I was just kind of sticking it back in for x and making sure it made it equal to. I don't want to make a mistake this early in the process. All right, now, there's another kind of critical number, And to me, it is more of a question. So again, if you look at critical values, part 2, check for division by 0, undefined, question mark, division by 0, question mark. All right. Now, I'm going to leave this up here on every question, every example as a template. But in this first example, you'll notice that I did put division in the question. And I hope you remember that any value of x that would make that denominator in that fraction equal to 0 is going to cause problems. So it turns out that 10 would be a number that would cause division by 0, and it's therefore critical. Dun, dun, dun. All right, so we have our critical numbers, and now what I would suggest do, and I'm so excited, I'm about to become a game show host and live my dream. So what I would do at this point is I'm going to make a number line here to represent all the values that x could possibly be. Okay, I'm a very visual person. So we're going to put these critical numbers on a number line. And we notice that 5 was a critical number, and so was 10. And now we're about to label why are they critical. Well, again, it's all about mathematical relationships. Let's remember that the number 5 was the number that made that fraction equal to 2. So if we look at this question, we would say, you know what, 5? Since you make them equal, you answer that, you work, right? You give us one of the relationships that the question wanted. That fraction wanted equal. So I would put a very solid, notice I'm putting a very solid dot on that 5 to indicate that it is indeed a solid solution to this particular equation, to this particular question, all right? Because of the equal. Now, as far as undefined, undefined is never something we want in math. 10, if you stick it into this question, is going to cause division by 0. And that's always, always, always bad. So I'm going to label that as UND for undefined. I don't know if you can see the colors, but green works in the question. Red does not. That's red. And so here's the deal. Visually, if we want to show people, don't put 10 into this question, it won't work. It causes division by 0. Then the visual that we put on a number line is an open circle, a hollow, to show that number does not work in the question. So, and that'll have implications towards the end of the question when we move forward and write up our final answer, which we'll talk about later. So what this did is it broke the number line into 3 intervals, 3 regions, 3 neighborhoods. And I hope you would understand that we have yet to discuss what numbers give us the greater than relationship that's in the question. Because that fraction wants numbers that also create greater than. And so to me, we're looking for that greater than relationship. So we're going to test some numbers, just like you test a person when you go on a date with them to see if they give you the relationship that you want. All right. Ladies and gentlemen, when Mr. Sonatan was a child, he wanted to be a game show host. That was his dream job. And so today we get to live out that dream. I wanted to share with you that I once heard somebody say that if you want to come up with your game show host name, what you do is you take your first pet and then you take the holiday that you were born closest to, and that will formulate your game show host name. So my first pet was my dog Sparky, and I was born on St. Patrick's Day. So my game show host name is Sparky St. Patrick. All right. My wife Helga, for example, her game show host name is Coco Independence. And my daughter, Andy, I believe that her game show host name would be Sammy Easter. So anyway, I'd be curious to hear what your game show host name would be. Again, it would be your first pet and the holiday you were born closest to. So I'll tell you what, if you're watching this, when you turn in assignment 16, if you want to write down what your game show host name would be, how about we'll give you an extra credit point just for doing that, all right? So have fun with that. But anyway, we're about to play the dating game. And this is where, again, I get to live my dream of being a game show host. We'll have to cue up the introduction here.
It's the dating game!
And I have to start over on that because, this is a one-man show again, all right? So we'll start over that. And it's about time to play the dating game, ladies and gentlemen. So here we go.
It's the dating game! And here's the star of our show with your host, Sparky St. Patrick.
Welcome to the dating game, ladies and gentlemen. I am your host, Sparky St. Patrick. It is great to have you with us today. And now here we are. We're looking at the fraction here. Our contestant is looking for values of x that will make that fraction either greater than or equal to 2. Now we've already discovered the number that made equal. That 5 gives us that relationship. We also talked about the fact that 10 would be a bad number because it makes division by 0. But we need to go determine the numbers that will give us the greater than relationship. Are you ready to play? Yeah! All right, thank you, ladies and gentlemen. So, we have 3 intervals here, 3 neighborhoods, and we need to go on a date with a number in each of these neighborhoods to see which of these numbers would give us the greater than relationship that the fraction desires. So, from left to right, let's go through these neighborhoods here. Our first contestant is a number that lives below 5. Please welcome to the show, 0. 0. Let's pick 0. It could be any number that lives in that neighborhood, but 0 represents all the numbers that live below 5. Welcome to the show, 0. So tell us, 0, about your date. Well, I showed up and I took the place of her ex. That sounds good. So you took the place of x. Yes! So we put 0 in for x. Everywhere there's an x, we replace it with the number 0. And it's like we're going on a date with the number 0 to see what relationship it gives us. So the question becomes, if we go on a date with 0, how does it make this fraction relate to the number 2? We don't know yet. It's too early. We just started dating, didn't we? We need to evaluate our relationship to see what happens here. So, we do the order of operations because our dear Aunt Sally came along on the date. Ew. But anyway, if you crunch the numbers after plugging 0 in for x, the numerator of that fraction becomes negative 15, and the denominator is negative 10. And we've got that 2 sitting over there. And again, we're not quite sure what the relationship is. And so there's one more operation, the fraction bar, which means division, right? So they pause at the door and they share one last little division together. And I guess that comes out to be 1.5. And I think the date's over and we're ready to make an interpretation, aren't we? So the question is, how does 1.5 compare to the number 2? Well, it's less than, isn't it? And the fraction wanted numbers that make it greater than 2. So that's the wrong relationship. That test number in that neighborhood below 5 gave us a less than relationship, and that isn't the relationship that the fraction wanted, is it? So it failed. Oh, man. So, we call up the number 0, and we say, hey, 0, thanks for the date last night, but you know what? You didn't give me the relationship I wanted. So, I'll tell you what, tell all your friends who live in your neighborhood below 5, don't call me. Leave me alone. Goodbye. But we don't give up. Let's move to the next neighborhood. Our next contestant is a number that lives between 5 and 10. Please welcome to the show, 7. 7, 8, 9, it doesn't matter. Let's go on a date with 7. 7 represents all the numbers that live between 5 and 7. Hi, 7, tell us about your date. I took the place of her ex. Same thing, right? Okay. So anyway, we go put 7 in for x. This is what is meant by going on a date with 7. And we're going to see what relationship that leads to here. So this time, and again, we just crunch the numbers over here. This is just the order of operations. We would do the numerator, which is -8, and we do the denominator, which is -3. And again, I'll put well, I don't know what the relationship is yet. The date's not over. There's still that division left to do, isn't there? So anyway, -8 divided by -3 becomes positive 2.6 repeating. And 2.6 repeating is, how does that relate to? What relationship did that number generate? Well, that number is greater than 2. Oh my gosh, we wanted greater, didn't we? It looks like that number worked. Wow, yay, that's the relationship we wanted. That makes me so happy.
Hey, there she is.
I must have slipped. Anyway, yes, that number is one of our dream girls. Apparently, if you live in that neighborhood between 5 and 7, you're going to make that fraction greater than 2. So you call up 7 and you go, thanks for the date last night, 7. You know what? You gave me the relationship I have been seeking my entire life. And you know what? All of your neighbors that live between 5 and 10 are going to give us the relationship we want. So you are a neighborhood that we really like. And you can take that however you want. All right. Let's go on a date with a number that represents all the numbers that live above 10. And again, we can pick any one of them. I tend to like to pick numbers either 0 when I get to its neighborhood, or maybe, how about 20? All right, hi 20. 20 takes the place of x. So when we go on the date, that's really just mechanical arithmetic, honestly. And so the point would be, what does that number do to the fraction? How does it make it relate to 2? So again, the numerator would be 5, and the denominator would be 10. And I don't think this is looking too good, but let's go ahead and crunch that out. 5 divided by 10 would be 0.5. It's mechanical arithmetic. And now the question is, how does that 5 relate to, or pardon me, how does 0.5 relate to 2? And it is less than. And you look up here and you say, well, that's not good. We wanted greater than. So it looks like that one failed. It didn't give us the relationship we wanted. And so it looks to me like just that middle neighborhood, just that middle interval gives us the relationship we want. So as far as that test number, nope, wrong relationship. So basically it's just a matter of sticking these numbers in and seeing which ones generate the relationship in the question. Now we need to talk about how to write up the final answer. The instructions were to write this in interval notation. And so again, hit pause anytime you wish. But I'm going to now take away all that work. It's mechanical arithmetic. Stick a number in for x and do the order of operations. And, all right, in math, when we have a range of numbers that satisfy a question, we write out what's called an interval notation. And the way you write it is you go from left to right. So as we look at this from left to right, the first number we see that actually worked in the question was 5, wasn't it? So we start with the 5. And we put a comma, and then up here 10 is on the upper end of the interval. Okay. And then we put a symbol next to these numbers to indicate whether they are to be included in the final answer or excluded. That's the reference here under critical values, include brackets, exclude parentheses. So we look at the 5, and as mentioned earlier, we say, well, 5 made them equal. An equal is in the question. 5 works. It's one of the relationships in the question. We put a squared off bracket next to the 5. That's the math symbol for, yes, include 5 in the solution set. All right. On the other hand, 10, since it created division by 0, which is always, always, always to be avoided, how do we show people, don't include 10 in your solution set, don't put 10 in for x, exclude parentheses, rounded, all right? So this would be the way that a mathematician would describe that picture, every number between 5 and 10, including 5, not including 10. That, ladies and gentlemen, concludes this episode of The Dating Game. I hope you enjoyed it, and I hope it made sense.